So I am also leaving this 1 and 2 to you. Okay, it's straightforward. Consider the case where f of x is this monomial and g of x is also like that, another monomial where I and j are both positive integers and potentially different. Okay, there is no reason for them to be equal. They may be equal, may not be equal. Where I and j are both positive. No need to even mention that they are integers. That's understood, right? Because polynomials look like that. Here, in a polynomial, you do not have fraction or irrational numbers. Okay, that is meaningless. So they are positive. Now, let us just simply carry out the calculation. If one directly tries to calculate this derivative of the product, first of all, what will the product be? The product, just simply by the definition of multiplication of two polynomials, is this, which again is a monomial. But now by the definition of derivatives, this is I plus j times x to the power I plus j minus 1. Okay. Now let's use the distributive law and write this. Well, I should not have said let's use the distributive law, but rather using the definition of addition of two polynomials, we get this from this. Now, if you look carefully, you can write the first term like this. You can split it into two parts. One of them is I times x to the power I minus 1, and the other one is x to the power j. Similarly, this second term can be split in this way: x to the power I times j times x to the power j minus 1. Now this one is nothing but the derivative of f, and this one is of course just simply g. This one is f and this one is the derivative of g. So you see that in this very special case where both f and g are monomials, the formula is true. Now all you have to do is you have to understand that if you take the product of two polynomials, then there you actually a polynomial arises as a linear combination of monomials with coefficients from your field. On that, if you apply this and use 1 and 2, then you will get 3. Let me just show you roughly how, but actually you should have already understood how. Suppose, so for that I need to consider expressions for f and g. Say f has this expression, let me use the summation notation, okay, to make things compact. Alpha I x to the power I, where say I varies from 0 to n is some non-negative integer, and say g is this polynomial beta j x to the power j, where j varies from 0 to n, where m is also some non-negative integer. Then what is f of x times g of x? We already know how it looks, right? We in fact have a rule for this, for writing the expression for this product polynomial, and that's why in fact I have also used the summation notation. So this will be, let me write it in the next line. Summation k, let me introduce a new index, from, it varies from 0 to n plus m, and here the coefficients will be multiplied in this manner: alpha I beta j, where I plus j is equal to k. So all the possible i's and all the possible j's, I say possible i's and possible j's because I can take the values from 0 through n and j can take the values from 0 through m. With that restriction, you have to collect those pairs I and j whose where the sum is k times x to the power k. Okay. And now if you differentiate, then while differentiating, what you have to do is you have to use parts 1 and 2, so that the process of differentiation gets inside the polynomial. First of all, the derivative of the sum of two functions is the sum of two polynomials is the sum of their derivative. If you extend this to the sum of any finite number of polynomials, okay, which can be done by induction, then the derivative of this goes inside. It becomes the sum of the derivatives of all these monomials. And there also, using part 2, you can take the derivative even further inside or towards that indeterminate x by taking these alphas. Alphas means that alpha in part 2, these constants outside the process of differentiation. And you will get this times whatever you have here, this thing, and then you have to write just this. So the derivative of this product turns out to be the polynomial which looks like this, where in place of these indeterminates, their powers, you have their derivatives, and there you use this fact. And then if you split the entire thing into two parts, you will see that you are actually getting the form of this formula back, even in this general situation. Okay, so this, in fact, there is no need to show this, but still if you want, you can go through all the details. So from this very special case and parts 1 and 2, the general part 3 automatically follows. So let me just end the video here itself. There are further things, of course, and one of those things, let me just briefly mention that thing, is that do you recall that there is a condition in calculus which tells you when a polynomial has multiple roots, when a polynomial function has multiple roots, namely that multiple root means it looks something like this. Say f of x is your polynomial function. Say that looks like this, which is the product of some other polynomial g of x and a power of x minus a. N is some positive integer greater than 1. Okay. Then a appears as a multiple root where a appears n times. Now such a thing happens if and only if both the function f as well as its derivative. Derivative means here I am talking about the ordinary calculus situation. Okay, so these are polynomial functions. If both f as well as the derivative have x minus a as a factor, so that such a result is true in this general setup also. So from that next lemma we will start in the next field theory video. So that's just it for tonight. Tomorrow again we have our usual, well, I can't say upload, but because we are using the community section for solving the exercises, so tomorrow you will see what will it be. What is the recent thing that we went through? Is it algebra problems from Lee? If that is so, then tomorrow we will see again group theory problems from Gallien's contemporary abstract algebra. Okay, so that's just it. So see you tomorrow with that in the community section. Until then, this is me, Lucifer, from A Mathematical Room. Have a nice night.